Hi, we are going to have a quick look at what do we mean by linear derivatives and non-linear derivatives. Now, when we talk about linear derivatives, let's look at a simple example. Let's assume that we have a future on an S&P 500 index. So basically, what that means is that let's assume that we have entered into a futures contract to purchase an S&P 500 index contract in 1 year's time. So the value of the future is simply the value of the index. Let's assume we have entered into the contract somewhere in January to purchase the 12-month futures index. So that's in December. So the value of the futures contract is simply the value of the index in 12 months time. Let's assume that it is 3005.52 multiplied by $250. So that's the value of the futures contract. Now we know that once we enter into a futures contract on a daily basis, the value of the futures contract can move based on the changes in the underlying. So let's assume that next day after we have entered into the contract, the 12-month index value, so the December future index value, the value of the index has moved from 3005.52 to 3006.52. Now what that means is that if you have a long position in this futures contract, in other words, if you have purchased this futures contract, you have just made a profit of $250 because you just multiply the change. So you can see from 3005.52 it has increased by 1 point to 3006.52. So you just multiply that by $250. So your futures contract has made a profit of $250 in 1 day. So you can see the value of the futures contract changes based on the change in the value of the index. In other words, this is the underlying. Remember, this is a futures contract on the S&P 500 index, and these are the values of the S&P 500 index. So what we are saying is the value of the futures contract changes as the value of the index, in this case the December value of the index. So because remember, this contract, this is a 12-month contract, so we are entering into the contract to buy the index as at of December. So as the December value of the index keeps changing, the value of our futures contract also will be changing. Now when we talk about linear derivatives, basically what we are saying is, irrespective of the value of the index, whether it's 3005 or whether it's 4000 or whether it's 2000, the change will always be linear. In other words, the change, whether it moves from 3005 to 3200 or whether it decreases from, let's say, 3005 to 2800, irrespective of what the move would be, whether it's a small move, in this case it has only increased by 1 point, whether it increases by 1 point or whether it increases by 20 points or whether it decreases by, let's say, 30 points, the change would be just simply the change in the index value multiplied by $250. So when we talk about linear derivatives, what we are saying is that the change will be always linear. It will be a straight line. In other words, if the S&P 500 index value, let's assume it's quite small, somewhere here, and it moves by, let's say, 10 points to here, then your futures price also will move by the same proportion multiplied by 250. Now whether if your S&P 500, let's assume that it's somewhere here and it moves by 10 points, or it moves by even 100 points, again your change in your futures price would be simply $250 multiplied by the move. So what we are saying is the change is always proportional. In other words, the delta, in other words, the change in the S&P 500 over the change in futures price is a constant, and the constant is $250. So that's what we are saying. When the index changes, the futures price is going to change. The ratio between the two changes is a constant of $250. So in that case, we call it a linear derivative. So remember, when we talk about linear derivatives, what we are saying is that now in this example, this is called a risk factor, because as the value of the index changes, the value of the future will change. So this is called a risk factor. So what we are saying is the change in the risk factor to the change in the derivative, the percentage will be always constant. Another example, let's look at a forward, FX forward. So we know that the formula for an FX forward is simply the spot price multiplied by the exponent of the risk-free rate in the local currency minus the risk-free interest rate in the foreign currency. So that's the foreign currency. And then we multiplied that by the time to maturity. So if you just want to calculate the forward FX price, you just simply take the spot FX price, and then you use the interest rates in the local currency and the foreign currency. You take the difference and you multiply it by the time to maturity, and you will arrive at the future FX price or the forward FX price. Now for shorter maturities, so let's assume very short maturities, let's say it's a 1 month contract. For shorter maturities, on a daily basis, the interest rates don't change much compared to the spot FX price. So for shorter maturities, so that's what we are saying here, for shorter maturities, we can say that the change in the forward price can be approximated. So remember the term. In other words, it can be roughly approximated to the change in the spot FX price. So what we are saying is, for if an FX forward has a shorter maturity, the change in the spot FX and the change in the forward FX price, this has a linear relationship. So one thing you need to understand is, when we talk about linear derivatives, it also matters in respect to which risk factor we are talking about. So in this case, spot FX price is a risk factor, because remember, if the spot FX price changes, the forward FX will change. Now the risk-free interest rate in local currency is also a risk factor, and the risk-free interest rate in foreign currency is also a risk factor, because if any of these changes, the forward price will change. But what we are saying is, when the maturity is short, for shorter maturities, something like 1 month or even 3 months, the interest rates don't change as much as the spot price. So the spot rates on a daily basis can change much more in comparison to interest rates. So what we are saying is, approximately, the change in the forward price and the change in the spot price has a linear relationship. Now this might not be true for longer maturities, because in longer maturities even interest rates will come to play, and you can see that this is not a linear relationship. That means when interest rates changes, the change in the forward price will not be linear. In other words, the ratio of change will not be constant. So these are linear derivatives. The same way, we can also show that if you take an interest rate swap, remember, in an interest rate swap, the value of the interest rate swap depends on the changes in interest rates. Now, even though generally we say interest rate swaps are linear derivatives, for longer maturity interest rate swaps, it is not linear. In other words, the relationship between interest rates and the swap itself is non-linear. In other words, it will not be in a straight line, it will be a curve. And these are called non-linear derivatives, which we will look in another video. So remember, in a linear derivative, what we are saying is the change in the risk factor, in a specific risk factor, compared to the change in the derivative will always be a constant. You can see this is a straight line. That means the slope of the line is always the same. That's what we mean by the change in the risk factor compared to the change in the derivative is always a constant, because the slope is a constant. In a straight line we have only one slope. So these are called linear derivatives. Now in the next video we will look at non-linear derivatives and why it's important to understand non-linear derivatives as well. So if you have any questions, post it on the comment section or drop us an email. And if you enjoyed this video, you can click like and subscribe to our channel, and we'll be posting more similar videos. Thank you.